Well, before turning into what exactly derivatives are, let us try to calculate derivatives. For example, suppose fx equals to just 2x, and you want to find out the derivative of this function at x equals to 2. Now, how do you calculate derivative is that derivative is given by, say, this f dash 2. Okay, there are different notations in order to express derivatives. We'll talk about that. Then you calculate the limit of this function, that is limit of h tends to 0, f of 2 plus h minus f of 2 divided by h. Now, what is f of 2 plus h? F of 2 plus h is wherever x is, you'll just write 2 plus h. This will be 2 into 2 plus h, which is 4 plus 2h. What is f of 2? Which is 2 into 2, which is equal to 4. Okay, you will just substitute these values there. So in place of f of 2 plus h, you will write, you'll first of all write this limit of h tends to 0, and in place of this you will write 4 plus 2h. In place of f of 2 you will write 4 divided by h. So what is it that is remaining here? Limit of h tends to 0, 2h by h, which is equal to 2. So in this case, f dash 2 is equal to 2. Now, the reason before telling you the definition of derivative, we have done this because you'll be able to relate it better. Okay, once you know how to calculate it, then you can relate to the formal definition better. So there are reasons why we have picked up 2 plus h. Okay, and I think it'll become more clear to you once you take up the next example, which is, suppose in case we had the function earlier, we had this function fx equals to 2x. Let us complicate this function a little bit, which is fx equals to 2x plus x square plus 5, and you have to calculate the derivative of the function at 2. Okay, so how do you write this? That is f dash 2 would be equal to limit of h tends to 0, f of 2 plus h minus f of 2 divided by h. So what is f of 2 plus h? Wherever x is, you will just write 2 plus h. 2 into 2 plus h plus 2 plus h square plus 5, which will be equal to 4 plus 2h plus 4 plus h square plus 4h plus 5, which will be equal to, once you simplify this, h square plus 6h plus 13. And what is f of 2? This is basically equal to, wherever x is, you'll just write 2. Okay, so you can write this as, that is equal to 13. You getting the point? Then you will substitute these values which you have found out. So limit of h tends to 0. You'll write f of 2 plus h is h square plus 6h plus 13 minus f of 2 is 13 divided by h. So this will become equal to limit of h tends to 0, h square plus 6h by h, which is equal to limit of h tends to 0, h plus 6. So which is equal to 6. Fine. So these are the two examples, and what we have done here is that we have tried to find out the derivative of the different functions using the first principles. Okay, now in the next recording we will formally define derivative, and we'll let you know that what is the background of using these first principles and why we have used them, what is derivative, what exactly derivative is trying to find out. Okay.